Hi everyone. In this lesson, we're going to learn about the properties of equality, and then we're going to learn how to use these properties to write geometric proofs. So we have a few properties here. The first property that we're going to look at is the reflexive property of equality, and we do have symbols in this column, but we're going to go directly to the definition and then the examples here. So the reflexive property says that equality is equal to itself, which is pretty obvious, such as 5 is equal to 5, or if we have a measure or we have an angle whose name is A, then the measure of angle A is equal to the measure of angle A. In number 2, we have the symmetric property of equality, and it says that an equality may be written or may be expressed in either order. So you could write x is equal to 4 or 4 is equal to x. And the other example, measure of angle A is equal to 40, which could also be written as 40 is equal to the measure of angle A. So this says that if you ever have something like the first equation that we have here, and then you want to get to the second equation, you could do that. You could write it in that different order, and you could justify it with the symmetric property of equality. In number 3, we have the transitive property of equality. And this says that if two quantities are equal to the same quantity, then these two quantities are equal to each other. As we see here in the example, if measure of angle A is equal to 50 and measure of angle B is equal to 50, then the measure of angle A is equal to the measure of angle B. So what does this say is that if you have two quantities that look different initially, but both of them are equal to the same quantity, then these two quantities that look different are really equal to each other because both of them are equal to 50 in this case. So what this says is that you can actually combine two equations into one by using the property or the transitive property. In number 4, we have the substitution property of equality, which we use a lot in algebra as well. And it says that a quantity may be substituted for its equal in any expression. And so we have here in the example, if the measure of angle A plus the measure of angle B is equal to 50, and measure of angle B is equal to the measure of angle C, then the measure of angle A plus measure of angle C is equal to 50. So what we have here is that this measure over here has been substituted by what's equal to the measure of angle B, and what's equal to measure of angle B is the measure of angle C. So we cross out measure of angle B and we write in that place measure of angle C. That is how we get from the first equation to the result by combining both equations. And if we ever do that, then we can justify that by using the substitution property. In the following, number 5, we have the addition property of equality. And it says that if equal quantities are added to equal quantities, then the sums are equal to each other. So this is also a property that we use a lot in algebra, especially when solving equations, as we see here in the second example. But in a simple example, what we have is this. If you have two quantities that are equal, such as 8 equal to 8, and then we add quantities that are equal, such as 3, which is equal to 3, then the results should also be equal to each other. And we see over here 11 equal to 11. So in the second example, we have the equation 2x minus 5 is equal to 13. And one of the steps that we need in order to solve for x is to add 5 on both sides. So whenever we do this, we're using the addition property of equality, and we know that the results are still equal. So whenever we do that, we can justify by using the property, the addition property of equality. In number 6, we have, very similar to number 5, we have the subtraction property of equality, which says basically the same thing but with subtraction. So if you have two quantities that are equal, such as 10 equal to 10, and then you subtract equal quantities from both sides, such as 4 on both sides, then the results are equal, as we see here, 6 equal to 6. And in the second example, it's a geometry example, we have an equation that represents the situation in the diagram. So we have the equation measure of angle B plus 30 is equal to 90 degrees. And if we want to solve for the measure of angle B, if we want to find the measure of angle B, what we have to do is subtract 30 on both sides. And so the measure of angle B is 60. And in this case, here we're using the subtraction property of equality. Next, in number 7, very similar as well, we have the multiplication property of equality, which says the same thing, only with multiplication. If you have two equal quantities, such as 5 equal to 5, and then you multiply by equal quantities on both sides, then the results should also be equal, as we see here, 10 equal to 10. So whenever we do something like this, we're using the multiplication property of equality. In number 8, we have the division property of equality, which is very similar, only with division. So it says that if you have two equal quantities, and then you divide those equal quantities by also equal quantities, such as 5 on both sides, then the results are also equal. So whenever we do this step, which is dividing both sides by the same quantity, we're using the division property of equality. And the last one is the partition property of equality. And this property, which could be new for all of us, says that a whole is equal to the sum of its parts. So the word partition is coming from the word parts. So it's just saying that an entire thing, such as an entire angle, is equal to the sum of the parts. And in the example that we have here, the measure of the big angle DEF is equal to the measure of angle A, which is one part, plus the measure of angle B, plus the measure of angle C. So whenever we add the parts that make up the whole, we're using the property, the partition property of equality. And the important thing about these properties is not only being able to identify them, but also use them in proofs, in geometric proofs, which is what we're going to be doing in the next few lessons starting today. And what is a proof? A proof is it's a procedure in geometry that consists of steps that are logically connected one to the other, and we use it to show that a statement is true. So we want to get a conclusion and show that that conclusion is true. So let me just show you how it looks like. We usually write the proofs such as a T-chart. It has to be 2 columns always, and this column is going to be the statement, what we call statements. Let me redo it because this is not looking good. So here we will have statements, and here we will have reasons. We usually have a list of statements here. They are all number, and the reasons are also number, so that we know which belongs to which one. And so for every statement that you write, you must have a reason, which is what we have been calling until this point justifications. It's actually, that's the reason why we have been justifying, because we have been preparing to write proofs. So what we have over here would be some statements, and here would be the justifications, which could either be a definition, it could be a theorem, or it could be a property that is being used to justify each statement that you have written over there. And the last statement that you have over here should be the conclusion that you want to get. So we're going to see examples of these today so that you can understand a little bit of what I'm talking about. So we're going to go to page number 2. So the proofs here are already done. Of course, that is not the way that we do proofs. We plan and they write the proofs, but I'm showing you this way because that's the only way that I can do it in a video. But we're just gonna forget about these proofs, make yourself believe that it's not there, and we're going to start from 0. So what we have to do, it says write a clear and organized 2-column proof and then justify each step of the proof. So the first one says, given that angle M and angle Q are right angles, prove that the measure of angle M is equal to the measure of angle Q. So let's examine what we have over here. Since it's probably the first time that you're seeing something like this, what are the things that we have over here? There are 2 things that we usually have over here. We have this part, which I'm going to underline in blue, which is the information that is given to you, and we actually call them givens. And we use this information to start the proof. This is what you are given so that you can start the proof. So this is what you know. And then we also have what we call the proof statement. What is it that you need to show that is true? You need to show, in this case, that the measure of angle M is equal to the measure of angle Q for this diagram that we have over here. So we use the information that you are given, and then we use some steps until we get to our conclusion that should be the measure of angle M is equal to the measure of angle Q. What's very important is that this proof statement should be the last statement in the proof. So going back to the previous page, here, when it says conclusion, this should be the last statement. So the proof statement should be here. Whenever you see that proof statement written here, that's when you're done with the proof. That's how you know that you're done with this procedure and you don't have to write anymore. So what you want to prove should be your last statement. So we go back to page number 2. So let me hide the proof because we're going to start from 0. So we'll analyze the diagram that we have and the givens that we have and see what can we get from the information that is given to you. So we're going to plan, first of all, here in this space that we have. And in our first proofs, we usually write the plan, but eventually you should be able to do the plan mentally and then just write the proof. But since this is our first time, we're going to plan the proof. So we start with the information given. What do we have? We have this, and I'm going to write it down. We have that angle M and angle Q are right angles. And this information has been given to us. So that would be the reason for us writing this on the proof, because that's given to us. And now we will think about, what does this mean? So what does being a right angle mean? In other words, we need to go back to the definition of right angles. What does it say? And the definition of a right angle says the following. A right angle is an angle that measures 90 degrees. So we can say that the measure of angle M and the measure of angle Q are both equal to 90 degrees. So let me write that over here. We know that the measure of angle M is equal to 90 degrees, and the measure of angle Q is also equal to 90 degrees. And why do we say that? It's because we're using the definition of a right angle. Definition of right angles. And now look at what we have right now. We have the following thing. We have these two equations. Measure of angle M equal to 90 and measure of angle Q is equal to 90. So look at what we need to get. We need to get exactly this thing over here. Measure of angle Q is equal, measure of angle M is equal to the measure of angle Q. So how can I connect these two equations and make these two equations into one? Well, we look at the properties, and there are actually some properties that will help us to combine two equations and into one. So we have the transitive property of equality, and we have the substitution property of equality, which allow us to combine two equations into one. And in this case, we're going to be using the transitive property because it says that if two quantities that look different are both equal to the same quantity, then these two quantities are equal to each other. And actually, that's what we have in our proof. Going back to the proof, we have two quantities that look different, but both of them are equal to 90, which means that both of them, or that they are equal to each other. So the measure of angle M is equal to the measure of angle Q. And so as you can see here, I have exactly what I need to prove, which is the measure of angle M is equal to the measure of angle Q. So what was the property that we used? That would be our reason here, and that was the transitive property. So now I'm going to show you the proof, which is already done, which should not be that way. We should get from what is our plan to our proof. Only now it's already written for you. And I'm gonna make it smaller so that we can see everything together. So if you look at the plan, it's exactly what you have in the proof. That's why you have to plan first, so that when you start writing the proof, you already know what is it that you are going to write. So I have the same thing here. I have measure of angle M, angle M and angle Q are right angles, and that is the information that we were given. And then what does it mean to be a right angle? It means that the measure of angle M is equal to 90 and the measure of angle Q is equal to 90. And why do we say that? Is because we're using the definition of a right angle. And then we combine these two equations by using the transitive property in this case, because you have two quantities that are different, but both of them are equal to the same quantity. So we can conclude that they are equal to each other because the transitive property allows us to conclude that. So that is the end of the proof, because we have here our proof statement that we have as well here on the top. Let's take a look at the second proof, and let me hide that so we can just take a look at what we have in the diagram and plan our proof. So in this case, if you read it, it just says prove that the measure of angle M plus the measure of angle B is equal to 90 degrees. We do not have the given information, so basically the only thing that we're given is the information that is on the diagram. So we will think about how do we prove that the measure of angle B plus the measure of angle A is equal to 90 degrees. These angles are separated from the other. Well, they just need to be complementary, because we know that complementary angles are to 90 degrees. So what I have here in this angle is a right angle. And so these two angles here, this one and this one here, are to 90 degrees. Actually, I'm going to put a name to that angle so we can call it by a name. So let's call this angle C. And so because they are forming a right angle, we actually know that they are to 90 degrees. So we can actually write that. That's something that we know from the diagram. That's sort of our given. So let's write that. So we have that the measure of angle B plus the measure of angle C is equal to 90 degrees. And we know that because they are forming a right angle, and so that makes these two angles complementary. So that will be our reason. We have here complementary angles. And if you look at the diagram carefully, you can also notice that angle C and angle A are actually vertical angles. So they have the same measure, and we can write this down. The measure of angle A is equal to the measure of angle C because we have vertical angles. And we know that vertical angles are congruent, and so they have the same measure. And therefore, since the measure of angle B plus the measure of angle C is 90 degrees, we can actually conclude that the measure of angle B plus the measure of angle A is equal to 90 degrees because we can use substitution here. We can substitute measure of angle C by what's equal to measure of angle C, which is the measure of angle A. So we can actually write in the place of measure of angle C, measure of angle A, because we're allowed to do with the substitution property. And so that's how we will get to what we want as our conclusion, which is this measure of angle B plus measure of angle A is equal to 90. So I'm going to write that here. Measure of angle B plus measure of angle A is equal to 90. And what we did, we simply substituted. So we use substitution. So let me show you the proof now so that we can see the whole thing. Again, we will plan first and then we will write the proof, because when you start writing the proof, you have to know what is it that you're going to write. So if you notice the proof that is already written, it's exactly the same thing as my plan. And it should always be like that. So I started by saying the measure of angle B plus the measure of angle C is equal to 90 degrees, which we can conclude from the diagram, and because they're complementary angles. And then the second thing that I wrote, measure of angle A plus measure of angle C, no, measure of angle A is equal to the measure of angle C because they are vertical angles. And then we just substituted the measure of angle C by measure of angle A, and that's how we get to what we want, which is that the measure of angle B plus the measure of angle A is equal to 90 using substitution. So it should be substitution property. And finally, the next one, I'm going to go directly to the proof. So we look at what is it that we're given. In this case, it says if angle 1 and angle 2 are complementary, and angle 2 and angle 3 are complementary, prove that measure of angle 1 is equal to measure of angle 3. So we have this part, which I'm putting in green. This would be the information that is given to us. It doesn't say given, but that is what's given to us. And the proof statement is here. We have to prove that the measure of angle 1 is equal to the measure of angle 3. So we can start with the given. Let's look at the first part of the given, which is angle 1 and angle 2 are complementary. What does it mean to be complementary? We will write down in our next step. First, we're writing the given. Angle 1 and angle 2 are complementary. Then we're writing the second part of the given, which is angle 2 and angle 3 are complementary. That's given to us. So what does it mean to be given? What does it mean to be complementary? That's written on the second step because it should be connected to what the first step says. So complementary means that the measures add to 90 degrees. So in this case, it would give us the measure of angle 1 plus the measure of angle 2 is equal to 90. And the same thing for the other one. Measure of angle 2 plus measure of angle 3 is equal to 90. And we're using the definition of complementary angles. And now, since we want to get this conclusion, measure of angle 1 is equal to the measure of angle 3, we want to find a way to combine these two equations into one equation. And we again can use the transitive property because we have these two quantities that look different, both being equal to 90, which means that they are actually equal to each other. So that's what I write over here. Measure of angle 1 plus measure of angle 2 is equal to the measure of angle 2 plus measure of angle 3 by the transitive property. And so we're just one step to getting to our conclusion. So now, how do we get from step number 3 to step number 4? If you notice on both sides, we have measure of angle 2 and measure of angle 2. So we just need to get rid of that from both sides so we can get measure of angle 1 is equal to measure of angle 2. So since we are adding measure of angle 2, to get rid of that, we will need to do the opposite, which is subtracting. So I will subtract here measure of angle 2. And since I need to do the same thing on both sides, sorry, this is not looking good. So let me rewrite that. So we need to subtract measure of angle 2 on this side. And we also need to subtract measure of angle 2 on this side. So these two measures of angle 2 are going to disappear from this side, and these two also disappear from this side, leaving us measure of angle 1 is equal to the measure of angle 3. And what did we do in order to get that? We simply subtract. So we're using the subtraction property of equality. So this is how we use the properties of equality in order to write proofs. So in this homework, the homework for this lesson, you will not have to do these proofs. I just want you to practice with solving problems with angles. And then on the next lessons, you will need to write your own proof. So just keep studying these properties as always, and the theorems and the definitions, so that you are ready to write your proofs in the next lesson. So what we have done in this lesson, we have reviewed the properties of equality, and we have seen how to use the properties in order to write proofs.